One slider, the whole staircase will build itself. That's the beauty of procedural modeling. And today I'll show you how to build this from scratch in Houdini. So we will start by creating the structure of our staircase. And we will start with the steps. So we will use a line and make it horizontal by setting one in the Z direction. Then we will group the out point to later use it to create the poles. So we drop a group node, set the name and then the group type to points. And since we want to get the endpoints, we will just type 1 and it turns to yellow, so we know that this point is now grouped and we will be able to access it later. The main structure is built around a copy node. Then we will crank up the total number and offset the steps on the y-axis and copy them to create all the steps and use the rotate to make them turn around the center axis. And basically here we have the basic structure of our staircase. To get things nice and tidy, we will use a null node to reference the results of our graph and pack everything together under a panel to make things more clear. Now we will create the pillar by using a line, but this time we want this line to follow automatically the height of the staircase. So we will use the number of steps and the step height to compute the line height. So to do this, we will copy the number of steps and pass it as reference in the length of the line. It's too height for now. We have to multiply by the step height. So we copy the parameter and use the times sign and then multiply it by the passed reference of the step height. And this time the height automatically updates and reflects the number of steps multiplied by the step height. And if we change the step count, the pillar size automatically updates. The sweep node to generate a mesh from the line. And it's very handy, and it's a trick that I use very often, is to build from lines and then use the sweep node to create mesh from the lines. The same way, create a null to reference later the object and create a group, a panel group to make things nice and tidy. To keep our graph clean, we will use an object merge. So we will just drag and drop the object into the object merge to get things organized and visually clear. So we drop a sweep node. By default, the sweep node only outputs square tubes, but we need rectangles for our steps. So we will use a grid shape connected to the second input of the sweep node. We change that size to something like a real step, and we will use the second input cross section. Right off the bat is not working well, so we need to change the axis of the grid and then modify the rows, the subdivision of the grid to make it like we want. And the faces are reversed, so we need to reverse the cross section and close the steps by adding end caps. Then we drop a null to reference the node later. And make a group, panel group. And now we create another object merge, and we will gather all the pieces of the steps. So we create an object merge and we add some slots to merge several objects. This time, this way, the graph stay clean. So we will duplicate our object merge to get back our steps and use a blast to delete the group and inverse the selection to get the auto points. We'll start by creating the poles with a simple line that we sweep just like earlier, adjusting the radius and adding the end caps. Then we will use a copy to point to basically copy a pole on every single point that we get from our blast node. Connect both together to the copy node and boom, we got our poles. Create a null and a panel group to organize the graph, and there we go. Update, add a slot to the object merge, and just drag the poles to add it to our final mesh. To build the rating, we will get back our points from the previous step. Just copy them, and we will reuse them to build the structure of the rail by using an add node. And the add node basically creates a line from a selection of points. Use the by group, and then we will sweep it, adjust the radius, and adding an end cap, and there we go. The rail is done. For now, the railing is created at step height, but we need to raise it up. Let's rename this to be nice and clear. Yeah, so we need to use the line height to move up the railing. So basically copy the length and paste it as reference in the transform node. And we're done. Just like usual, just drop a null to easily reference this part, make a panel group, and in our object merge, add a slot and drag and drop the result. And there we go. We have our final staircase. Now if you go back to our copy node, we can change the stair count, the stair length, and everything reacts to our change. We can as well rotate more or less each step. But here we can see that there is some penetration with the steps and the pole, and we can fix it by carving the line of each step. Then we will drop a curve node and basically trim the starts of the line. But to control it and to make it automatical, we will use the radius. We'll copy parameter the radius and then paste it as reference in the curve node. It's better, but it's not perfect, because if we change the length, because the curve node is proportional, we need to divide it by the length of the step. And once we are done, we can change either the pole radius or even the length, the step length, and the step automatically fits. If you enjoy this content, please consider subscribing to the channel. It really helps. So thanks for watching.